Thank you. Can you all hear me well? All right. So my name is Dmytro. I currently work as a solution architect. And I used to work for Sitecore when XDB was being developed, which is why I know some things about how XDB works internally. And a word of warning, this will be pretty technical. And the presentation is about how context, sessions, and also clusters work in XDB. So first, I'll quickly remind what XDB is and describe how it can scale. And then I'll dig into how it deals with parallelism and give some tips on how to work with context APIs. So what is Sitecore XDB? If you're a brand, if you're a business person, then it's about collecting all the data you can get about your customers. Then you use reporting to gain as much insight as you can, and then you enhance the experiences of your customers. And hopefully profit in the end. And if you're a developer, it's completely different. You have some backend user interfaces, which as a developer you probably want to avoid, but you have to use them. And you have the data storage, or several types of it. And you have APIs. And of course you have the infrastructure, which you need to remember about. Yeah, so let's talk about scaling the infrastructure with Sitecore and with XDB. XDB was built to support both vertical scaling and horizontal scaling, and it's meant to be geographically distributed. How can you scale and distribute it? Well, the unit of scaling is a cluster. And when a user's request comes to a content delivery cluster, it gets to a load balancer. And the load balancer can distribute those requests to any amount of content delivery servers. And that's already where the scaling starts. You can add as many content delivery servers as you want inside a single cluster. Every cluster has its own session databases, and of course, the Sitecore databases, core and web. Okay, the next way of scaling is to create multiple clusters and to put them in different points on the globe. For example, here we see a US cluster and a European cluster. And visitors will go to the closest cluster based on where they are located. And this is implemented using geographically aware DNS. You can have, again, as many clusters as you want. And the next point of scaling comes with the data that you collect. All the pages, interactions are saved to the collection database. And there are processing servers. And I just learned how to do animations in PowerPoint, as you can see. So the processing of the data gathered can be distributed across many processing servers. And, okay, some more animations. And all the data is then aggregated and saved in a way that's very good for reporting queries and saved into the reporting database. So the point that we can take away from this is that XDB is a complex development environment. It's not just running on one server. It can scale, and there's a lot of parallelism involved. So when you write code, you really need to remember about that. And that's what I'm going to talk about next. Well, here's an example of how XDB handles concurrency internally. When XDB registers interactions, it saves them to the collection database, and the processing servers will process interactions. But how will they process them? What if there are thousands of interactions every minute? Well, the interactions are put into something called a processing pool, and they are then split into something called ranges. And this way, the processing agents that run on processing servers, they can pick a range and start processing it. And the range is locked to a specific agent, which means that a range of interactions, there is a dedicated agent for processing all of them. And of course, every agent then stores data in the reporting database. So I will not go into detail of how this is implemented exactly. It was just an example of parallelism. Now to the main points about XDB contacts. Just to remind, what's a contact? Well, it is a representation of a real person, and every contact can have multiple interactions across many channels, including robots, apparently. And all of this data, again, is stored in the collection database. And some scenarios that are coming up in my work and on the internet, there are a lot of questions, and I split them into the three most common scenarios. So when you work with contacts in your code, for example, you need to create a page where any user can update their personal information. Another scenario is when contact data import needs to run in the background. For example, if you're going to import data from some CRM system or any other source of contact data, you're going to need a background process for that, in most cases. And the third scenario is for administrators that can manually modify any contact. And the reason I introduced these three scenarios is because you're going to use different APIs in all of these. And there are, of course, there's more than one set of APIs, naturally. There are contact repository, contact manager, shared session state manager, and the tracker. I'm going to remind you about the shared session, why it exists. It's because every contact can have more than one simultaneous interaction or simultaneous visits on the site. It could be, in the simplest case, if the same person comes from a laptop, they open the site, and then they decide to open the site from their mobile phone as well. So there will be two sessions running in parallel, and they need to be able to access and modify contact data at the same time, which is why the contact session, it is shared between all interaction sessions. So these four APIs that I have mentioned, the contact repository, it works with the collection database. It looks directly into the storage of all contacts. And the shared session state manager, it looks into the shared session database. Contact manager unifies these two APIs, which means that if you request a contact through the contact manager, it will first look if the contact is present in the shared session. And if it's not, then it will query the contact repository directly in the database. It will load it, and it will put it into the shared session database. And the API that you can use directly in Pages is the tracker. Tracker current contacts. Their contact is not stored in any database. It's loaded into memory and is available directly from any page code. So if you don't know which API you should use, you're not alone. You'll need a lawyer, but we'll handle that. So I decided to visualize what happens and at what stages the contacts are located in which database or storage. So initially, when there are no sessions for the contacts on the website, the contact is stored in the collection database, or in MongoDB, in other words. Next, when a session starts, a contact is logged in the collection database. And here it's denoted using the red color. And the contact is copied and loaded into the shared session to a given cluster. And in the shared session, it is not logged at this point. And then on every page request, the contact is also logged in the shared session, and it is loaded into the tracker API, along with the interaction. And it is then available directly in your page code. When any given page request ends, the contact is removed from the tracker, and it is unlocked in the shared session. And at the end of the session, the contact is saved to the collection database. It is unlocked there, and it's removed from the shared session. So depending on where your code runs, you might want to use different APIs. And I will demonstrate it corresponding to the scenarios I outlined earlier. So let's say you need to access some contact in a page. It's, let's say, a page for updating your data. Like you want to change your email address or your last name or something. And then it's very easy. You use tracker.current.contact. That's the page code, and you don't care about any logs. The contact is always available for you. This is why it's the easiest case. Next one is a background process. And in this case, you need to use the contact repository. And you'll get your contact directly from the collection database. You don't have it on your cluster, or you assume you don't. And it might happen that the contact currently has a live session, or it is logged by another process. In that case, you cannot do anything. You cannot relock it. The only thing you can do is wait you'll need to wait until the contact is unlocked, and then you can modify it. And the most complex case is this one, where you are on a page, but the current contact is not the contact you're trying to modify. So first you can look if the current contact is yourself, basically. If you're an admin and you're editing your own data, your contact will be located in the tracker. If you're modifying another user, you will use the shared session first, because if a user has a session on the same cluster as your page is running, you can access it in the shared session of this cluster. And if the contact is not there, which probably means it doesn't have any live sessions, you will query the collection database using the contact repository. And once you have modified the contact, it's also important to save it to the same place where you got it from. Because if you lock it in the collection database and then you don't unlock it there, no other process will be able to access it. All right. I also wanted to tell you how exactly this concurrency control is implemented. And I wanted to start with some analogies. In the classic concurrency programming, you have some synchronization primitives, like locks and monitors, mutexes, semaphores, etc. Let's look at the spin lock. Let's say you have one processor that has entered a critical session. That means that it acquired a lock on some resource. And if another processor or another thread if it wants to access the same resource, it needs to enter the critical section, but it cannot until the first processor leaves the critical section. And what the second thread does, it actually tries to access it continuously, which is why it's called spinning. It tries and tries and tries until it succeeds. Then it enters the critical section, and yeah, it got the lock on the resource. So that's the spin lock. And there's also something called an expiring lock. And in this case, when the first processor locks a resource, it also indicates at what time the resource will be freed up. And if another thread or processor needs to access this resource, it knows exactly when it will be able to access it. So not to spend any resources, it just sleeps. And at some specific time, it wakes up and it accesses the critical section. So spin lock and expiring lock, two different things. And what's interesting is that this is multi-threading, right? But in multi-server programming, you are dealing with a similar kind of concurrency. And the contact repository operates with expiring locks, which are also called leases or lease locks. When a contact repository locks some contact in the collection database, it puts a log that indicates at what date and time it will be released. Normally, it's after 20 minutes of being logged, because that's the length of the ASP.NET session. And if another server or another process tries to access the same contact, it will see at what point it will be unlocked. And it can try again at that time. But there is no way to relock it. You just have to postpone your contact modifications. And the shared session state manager, it also locks the contact in the shared session database. But it can only, or normally it's only locked for the duration of a single page request. And that means that if your page load time is 1 second, it's probably already too high. But other processes on the same cluster will not have to wait longer than 1 or 2 seconds. And that means that this spin lock, you'll be able to acquire the lock after 1 or 2 seconds. So you don't have to postpone. This is not like an expiration lock. You're just waiting until this shared session state manager returns the contact to you. It just locks the thread, and that's it. And if you're working with a tracker, you're the only one who can access the contact. That means that your current thread has locked the contact in the shared session database. So you're guaranteed access. You don't have to worry about locking. So this is how it was implemented. And it's something that works pretty well. It may also be confusing for some people who are not familiar with these concepts of several types of locks and storages and all the workflow. So the contact gets through the collection database, through the shared session state, into the tracker. Lock a contact, there's nothing you can do. So there are actually alternative concurrency control models. It's not something that was implemented in XDB. It's just something that's interesting to consider. One is optimistic lock-in. And this concept is about assuming cases only one cluster or only one process will be working with a particular contact. And in this case, there would be no actual exclusive locks. Any process can load a contact, work with it, and save it. And if another process has modified the contact in the meanwhile, in that case, there will be some kind of merge process. But since statistically it only happens in less than 1% of cases, normally it's not a problem if two processes may modify the contact. You just assume you're the only one, and if there's a conflict, you just merge it. Again, this is not how XDB works. This is something that might be in the future, as I understand. And another interesting model is event sourcing. Event sourcing deals with write-only changes, and it's also similar to what Mark Cassidy described today in his presentation about service buses. If this was how XDB worked, then any change would be just queued, and you wouldn't read a locked contact or anything like that. You would schedule changes to contacts, and they would be written into the database according to some predefined merging logic. Yeah, this is just something that was interesting to think about for me. So Unfortunately, I couldn't hear the XConnect presentation earlier today. We'll all hear it tomorrow. But according to what I've heard, contact APIs needed by XConnect, and maybe even the lock-in model is going to be revised. But even if that happens for the next couple of years, maybe you will not all of the solutions will migrate to XConnect, which is why I thought it would still be good to describe exactly how the lock-in model works with contacts. So, as a summary, as a developer who writes code, remember always about concurrency, that your code is not the only code that may be dealing with contacts at this time. Then remember to use the correct APIs. If you have questions, there are Slack and Sitecore Stack Exchange. There's a lot of helpful people that know these things. And I'm going to look forward to XConnect to see what they are going to change about contacts. That's all I have.
Questions? We heavily work with engagement plans. And according to your model, where is my contact when it's going to be processed from one state to another?
Where it's located. I'm pretty sure that the engagement automation code, it logs the contact directly in MongoDB in the collection database. So normally it assumes that the contact doesn't have live sessions, and it logs it, it modifies it, and it saves it back.
If I want to create a custom automation action, and I want to update my contact, I should write it directly to contact repository.
Okay.
You should use the live session agent for that. You look on dev, SUGCON.net, there's a new agent we created that is designed for that exact problem. So if the contact is locked on the cluster, the engagement plan state will be processed on the CD and then returned back to solve that exact problem.
Well, thank you.
What that guy said.
More questions? One more questions?
Okay, so when you import contact data in the background, you're talking about postponing modifications.
Yep.
What is, in your opinion, the best way to do that?
Actually, it depends. The easiest would be to store it in memory in some kind of queue and process it in 20 or in 30 minutes. But that depends on how reliable your code to be. And you might want to have some kind of a queue that has dedicated storage. This way, even if your instance dies, another instance can pick it up and update the contact later.
Okay, thanks.
In the API, there are some methods that log the contact read-only. I assume, like after seeing your locking model, that you can still work with the contact, and I assume an exception is thrown when I try to save it then, or can you elaborate on this?
Yeah, those methods are not locking any contacts. They are loading them, as it's indicated by the name read-only. So you can get the data of the contact, but it's not safe to change it. Because when you try to save it, it might already be locked by another process, and you cannot do anything about it. And when it's unlocked, the original data might have changed by some merge, depending on what you wanted to change. So if you just want to read data, it's fine to load it read-only. If you want to modify data, you need to lock it.
Hi. So let's imagine that you have geographical distribution of data centers.
Right.
Now, let's say that in the United States, you get your session locked in your local cluster.
Right.
So you use that, switch off the VPN or do something, then you suddenly can be routed through Europe.
Right.
But you still have that active session on the timeout of those 20 minutes or so. So let's say that you get redirected to Europe. Now, Europe as a cluster tries to get the data from the collection database, sees that there's this lease active. And now my understanding is that there is an HTTP request to the United States cluster that starts the conversation. But is that correct? Did I got it right?
Well, what happens is that okay, so the contact will be locked by the US cluster in the collection database. When a user arrives to a European cluster, the European cluster will attempt to lock it, but it will not succeed because it's locked. But it will still be able to see the identifier of the cluster that currently holds the lock. And if you have set up XDB correctly, this identifier will actually be the domain name of the US cluster. So the server, or any server on the European cluster that tries to get the lock, it will know which other cluster holds the lock. It will issue a server-side web service request to transfer all data gathered so far in the session. It's because a contact might visit the site, but they might only identify themselves at a later point. So some data that's gathered is transferred server to server. And then the user will be redirected to that specific cluster via some kind of HTTP redirect. So the user's data will end up in the correct cluster's shared session, and the user will end up at the same cluster.
So the data will travel from the United States to Europe?
No. Actually, the other way around, because the cluster that originally holds the lock, that will be the cluster which gets all the data from the second cluster. Yeah.
Any more questions?
Hi, it may not be related to exactly that topic, but if let's suppose we are changing something in user information or contact information, what can be the best way to flush data into MongoDB? Because recently we have faced same problem, and we have to do session.abandon to explicitly flush data into MongoDB. So I think session.abandon is not a good idea.
Yeah, it's it might be okay. The problem is actually because the APIs, some APIs are inconsistent. There are actually two methods that flush data to XDB, and only one of them should be used. But in general, again, it depends on where your code is running. If it's in a page context, then you should only save contact data to the tracker, and then it will be saved automatically at the session end. But if you're implementing, what is it that you're implementing actually?
Actually, we are trying to save some information, and we want to see the immediate effect of that information, and that doesn't show anything till we are not doing session.abandon. So we have to do session.abandon to push data into MongoDB to see immediate effect.
So you're changing contact data through the tracker, I assume, and you want it to be saved immediately. Yeah, in that case, flush contact to XDB.
But flush also doesn't work without session.abandon. So we have to first do the flush method call and then session.abandon. But in between of the application, if we do this session.abandon, will it be the good way to do it? Or
in my experience, it works. It just saves data. But you might be using the wrong flush method, actually.
okay.
If you want, I can show you later.
Some inspiration in there for how we handle the opens and clicks. So when an open and a click comes through in EXM, we have to instantiate a session, write the interactions to the tracker, then flush it, then redirect them so it picks up the web session so that the opens and clicks are not counted as a part of the main web session so they can be identified correctly. If you download the EXM CD processing package, you might find some inspiration in some DLLs around there. Yeah, 3.3.4 or 3.5 that hasn't been released yet.
More questions? Okay. Well, a big round of applause here.
Thanks a lot.